Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in science and engineering subjects. Today in our class 12th physics playlist in our chapter electromagnetism, we'll study some application of Ampere circuital law and we will understand the magnetic field produced by solenoid and toroid, and we'll also discuss their practical applications and some exams and trick numericals. So let's start magnetic field of solenoid and toroid from Ampere circuital law. Ampere circuital law is an alternate approach for Biot-Savart law to analyze magnetic field, and in symmetrical magnetic field conditions by current distribution it become more convenient to calculate magnetic field parameters. Ampere circuital law states that closed line integral of magnetic field flux density around some assumed closed loop where magnetic field intensity is considered at boundary of this closed loop is equal to mu0 times the total current enclosed in that closed loop or the total amount of current piercing the area which get enclosed by the closed loop boundary. This solenoid and this toroid are two typical configuration of current carrying turns which generate strong uniform magnetic field for different applications, and in both solenoid and toroid the magnetic field produced got a high degree of symmetry, and in those symmetrical magnetic field conditions we can apply Ampere's law to make magnetic field calculation very convenient and simple. Now such solenoids are used to produce strong powerful uniform magnetic field in different electromagnetic applications. These solenoids are used in cathode ray tube type of televisions to generate strong magnetic field as required in picture production, and a typical synchrotron use both combination of solenoid and toroid to generate a very powerful strong magnetic field. Today we will discuss the relation of magnetic field flux density with current and number of turns in these solenoid and toroid configurations. First, discuss the construction feature of solenoid. Solenoid is a coil of insulated current carrying copper circular turns which form a helix over one axis. Now these turns of solenoid got identical radius and have close spacing with a little axial displacement over a cylindrical core. Practically, the length of solenoid is quite larger than its diameter, and in this solenoid, the plane of every turn is perpendicular to this solenoid axis, and they produce magnetic field when current passes through these turns in the same direction along the axis of solenoid, and the direction of magnetic field is given by right hand thumb rule. When the finger of right hand are curled along the direction of current in coil, the thumb perpendicular to these coil plane along axis of solenoid indicate the direction of magnetic field. Each turn of solenoid is regarded as current carrying circular loop, and the net magnetic field of this solenoid is vector summation of fields due to all these turns. Now to an external position, two adjacent current loop produce magnetic field in opposite direction and their vector summation nullify each other effect. So for a closely spaced helix of circular turns, the magnetic field at such q positions between two neighboring turns outside this solenoid vanishes. So we can say that the field outside this solenoid adjacent to its boundary is ideally zero or practically very weak, and to a quite far away position there may be a small component of magnetic field of returning force lines, whereas for interior positions like P, the magnetic field contribution of all current carrying circular loop acts in the same direction and add together, and they form a very strong and uniform magnetic field along the axis of solenoid. The magnetic field inside the solenoid is everywhere parallel to the axis of solenoid, and it is not only strong, also uniform at least in this middle positions, and these two extreme ends are also in between two adjacent turns. The magnetic field is only along the axis of solenoid and there is no component perpendicular to the axis along these arrow marked directions, as magnetic field everywhere is coaxial along solenoid axis in near vicinity, and these force lines return from a far away positions. So magnetic field just adjacent to solenoid outside positions is negligible small, and to far away position it is also quite weak, whereas to internal position of solenoid everywhere the magnetic field is not only strong and uniform, is also along the axis of solenoid. The sectional diagram of solenoid across its diameter is as shown here, and for this L length of solenoid there are total n number of turns, and when current flow through these turns and make circular helical loops, they all produce their resultant strong uniform axial magnetic field along the axis of this solenoid, and let the magnitude of that magnetic field flux density is B Tesla along the axis of solenoid at middle positions. To find out value of this magnetic field flux density by Ampere circuital law, consider a closed Ampere run loop ABCD of length L dash, and in this loop just outside the solenoid along CD path the magnetic field flux density is negligible small or considered as 0, and along path length BC and DA the axial magnetic field won't have any perpendicular component and there exists magnetic field only along AB length, and due to symmetry of current distribution this magnetic field along axis of solenoid is uniform, that is constant in magnitude and is in the same direction everywhere along axis of solenoid. Let total n number of turns in helical circular loop are wound in total capital L length of solenoid in an uniform manner with turns per unit length is the same all over the length, and the magnetic field produced at these central position is B Tesla. So from Ampere circuital law, when we take closed line integral of magnetic field flux density along this ABCDA closed path, then this closed line integral can be converted in 4 open line integral from A to B, from B to C, from C to D and back to D to A, and as per Ampere circuital law, closed line integral of magnetic field flux density is medium permeability mu0 times the total amount of current enclosed in that closed loop, and here these turns get unclosed by this ABCDA loop. Now along AB path both magnetic field flux density and displacement component are in the same direction, so angle between the two is 0 degree, and for BC and DA positions the angle between magnetic field flux density vector and elemental displacement vector is 90 degree, and cos 90 will make this part of integration 0, whereas for CD length just outside the solenoid, for this long solenoid the return of magnetic flux lines are very far away and two adjacent turns produce resultant magnetic field in opposite direction of equal amount to nullify each other effect. So to just outside position CD the resultant magnetic field is 0, so with 0 value of magnetic field flux density along CD path this part of integration also becomes 0. So this closed line integral of magnetic field flux density along this ABCDA path just become integration of magnetic field flux density along length with limits AB. So for this closed line integration of magnetic field flux density along ABCDA path, along path BC and DA, angle between magnetic field flux density and elemental displacement is 90 degree. So these two part of integration from B to C and D to A becomes 0 as cos 90 becomes 0. And for CD part of length, external magnetic field is 0, so this also becomes 0. So this closed line integral of magnetic field flux density becomes only part integration of magnetic flux density with elemental length from boundary condition A to B, and since everywhere the direction of magnetic field flux density aligned with axis of solenoid or AB length, so angle is 0 everywhere and magnetic field is uniform, so that constant value of flux density come out of integration, so this become only the integration of AB length, and that is L dash, and according to Ampere circuital law the closed line integral of magnetic field flux density is equal to total amount of enclosed Ampere turns in Ampere loop multiplied by permeability of medium, and if per unit length the number of turns is small n, then for L1 length the total number of turns become nL1, and that get enclosed here in this Ampere ABCDA path. So closed line integral of magnetic field flux density become mu0 times number of turns, and Ampere is enclosed in the path, and this simplification will become LDS get cancel out from both sides. So magnetic field flux density inside a solenoid become mu0 times small n I, where small n is number of turns per unit length in solenoid and I is current in solenoid turns. Now in place of turns per unit length, we can write total number of turns in solenoid divided by total length of solenoid, and our magnetic field flux density will become mu 0 Ni upon L for a solenoid for all internal positions. And this clearly indicate that the magnitude and direction of magnetic field flux density is everywhere the same along the axis of solenoid, especially for middle positions. And if solenoid is quite long, then we could have a very wide, uniform and strong magnetic field presence. For a solenoid close to these mid positions, the magnetic field flux density mu 0 times turns per unit length multiplied by current, or mu 0 total number of turns multiplied by current divided by total length of solenoid, is nearly uniform, and it decreases a little bit as we move towards end positions. Now the direction of this magnetic field along the axis of solenoid is given by Maxwell right hand rule, and according to that rule, if we curl right hand finger along the current in these circular helical loops of solenoid turns, then the thumb perpendicular to the plane of these circular turns indicate axial magnetic field, and we can increase the magnitude of magnetic field flux density in solenoid core area by insertion of some ferromagnetic core material of high relative permeability in place of air, and that could create a very strong, powerful and uniform magnetic field. For an ideal solenoid or very long solenoid, the magnetic force lines will return back from infinity and to near vicinity to outside position. Magnetic field is negligible small, and inside the solenoid everywhere the magnetic field is uniform and very strong. But in a practical solenoid, magnetic force lines form small closure loops, and there exists a small amount of magnetic field to outside positions, and magnetic field become strong and uniform in middle position of solenoid, and to extreme end positions the strength of magnetic field slightly decreases. And for a very long solenoid, the magnetic field at center position is 2 times the magnetic field at extreme end positions, or we can say the magnetic field from full maximum strength decreases to half to extreme ends for a very long practical solenoid. To understand magnetic field of a toroid, first understand the construction feature of toroid. Toroid is a hollow circular ring on which large number of turns in a helical manner are closely wound, and one can consider a toroid as a long solenoid which has been bent into a circular shape to close on itself. So a solenoid without ends closed in a circular shape becomes toroid. The given toroid coil got n number of helical turns, each carry I amount of current as shown in the figure, and these current carrying circular loops produce their individual magnetic field, and resultant magnetic field become a uniform magnetic field inside this core of toroid. And for this open space inside the toroid and this surrounding open space outside the toroid at position P and Q, the resultant magnetic field become 0, and the field inside the toroid core is uniform, constant in magnitude and everywhere along the axis of this circular ring. To find out magnetic field at internal empty space at R1 radius position from this center of circular core of toroid, and at internal position of toroid core or to outside open space of toroid core, we'll consider 3 closed Amperian loop 1, 2 and 3 on which we will apply Ampere circuital law. And if we consider the symmetrical current distribution of helical circular loop over this toroidal core with uniform and closed space helical turns, the magnetic field at all these 3 Ampere closed loop become tangential to considered loop, and at all 3 positions all over the closed loop the magnitude of magnetic field is the same. This first closed loop of radius R1 doesn't enclose or cut turns of toroidal current carrying coil, whereas this second loop of radius R and this third circular loop of radius R3 cut toroid and enclose the current carrying turns of toroid. This loop second enclose each turn only once, whereas this outer loop of R3 radius enclose and cut a loop twice with current in 2 different directions. The dot indicate current perpendicular to this plane towards us, and cross indicate the current direction perpendicular to this plane to inside away from us. To find out magnetic field in this internal empty space at r1 distance from center of this circular core, assume a closed Amperean circular path of radius r1 and the magnitude of magnetic field flux density over this loop is b1, and due to symmetry everywhere on this loop magnetic field is uniform, constant in magnitude and tangential to this circular loop, and as per Ampere circuital law, the closed line integral of magnetic field flux density at r1 distance over this entire closed loop become b1 times the circular periphery of 2 pi r1, where r1 is radius of this circular closed Amperean loop, and as per Ampere circuital law it is medium permeability multiplied by the total current enclosed in this circular loop, and all toroidal turns are outside this loop and there is no current which get enclosed in this. So as loop encloses no current, so this summation of enclosed current becomes 0, and neither 2 nor pi nor this radius r1 is 0. So it is only this magnetic field flux density at this circular loop boundary is 0. So everywhere in this internal empty space the magnetic field of this toroid core is 0. We can also prove that magnetic field at this point Q in this outside empty space surrounding this toroid is also 0, and for that let's consider an Amperean loop of radius r3 surrounding this toroidal core, and everywhere due to symmetry the magnitude of magnetic field flux density is b3 and magnetic field is, if exist, become tangential to this Amperean loop, and the closed line integral of magnetic field flux density around this r3 radius circular closed loop become b3 times 2 pi r3, as the magnitude of b3 is everywhere same and total circular length periphery for a one turn closed loop is 2 pi radius, and it is equal to medium permeability multiplied by the total amount of current enclosed in this circular loop. And if we see the cut section diagram, then every turn of circular loop is enclosed twice by this closed Amperean loop, and to one side this current is coming out perpendicular to this plane, and to other side it is going inside again perpendicular to this plane. So the two current equal and opposite in sense results in zero summation. So total algebraic summation of current in this r3 radius circular loop becomes 0, and neither 2 nor pi or nor this r3 radius could be 0. So the only thing is the magnetic field b3 over this circular loop boundary is 0. So there won't be any magnetic field to internal empty space of toroid core or outside surrounding positions. From symmetry of this current distribution, this toroid core will produce uniform magnetic field in this internal core of this toroid, and everywhere the direction of magnetic field become tangential to this circular core and the magnitude is the same everywhere. And to find out magnitude of this uniform magnetic field flux density, let's assume that its magnitude is b and consider a closed Ampere circular loop of radius r, and closed line integral of magnetic field flux density become a simple product of magnetic field flux density and elemental displacement. And since due to symmetry of current distribution everywhere the magnitude of magnetic field flux density is the same, so the constant flux density come out of integration and it become mere integration of elemental length, and for one circular loop of radius r this integration of length become 2 pi r, and according to Ampere circuital law this closed line integration of magnetic flux density is mu 0 times the summation of current enclosed in this circular loop, and all these turns with similar direction sense get enclosed by this Amperean loop. So total number of turns in toroid core capital N and current in each turn I become the algebraic summation of enclosed current, and simplification will result in the magnitude of magnetic field flux density as mu 0 times Ampere turns divided by 2 pi r, and this 2 pi r is mean length of toroid core, and number of turns divided by mean length of toroid become number of turns per unit toroid core length, small n, and we found that magnetic field flux density is medium permeability mu 0 multiplied by number of turns per unit length multiplied by current in toroid coil turns, And this result of toroid magnetic field flux density is the same as we have obtained magnetic field flux density of a solenoid. So this toroid is just like a closed solenoid and both produce the same amount of magnetic field flux density. Here in an ideal toroidal core, we have assumed that there is no magnetic field just outside or to inner sides, and everywhere in this toroidal core magnetic field is uniform with same magnitude and same circular directions. But in practical reality, there always exists a small amount of magnetic field to these external surrounding positions and internal empty space in a toroid core too. Simple formula based numericals are asked to find out magnetic field flux density produced by solenoid. As in this example, a closed wound solenoid is 80 cm long and it has winding turns in 5 layers and each layer got 400 turns. The diameter of this solenoid is 1.8 cm and if current carried by solenoid circular turns is 8 ampere, find out magnetic field flux density inside this solenoid at these middle positions. So it is given that solenoid length is 80 cm or 0.8 meter. The number of turns in 5 layer, each of 400 turns becomes 5 times 400 or 2000. Now the radius of solenoid is half of 1.8 centimeter or 0.9 centimeter or 0.009 meter, but in no calculation will use this radius, and the current in solenoid turn is 8 ampere, and we know the magnetic field flux density to middle position of a long solenoid is mu0 times Ni, where N is number of turns per unit length in solenoid, and here the total number of turns capital N is 2000 and the length of solenoid is 0.8 meter. So turns per unit length is 2000 by 0.8. Mu0 permeability of air is 4 pi into 10 to the power minus 7 and current in solenoid turns is 8 ampere. And when we simplify this relation, 8 divided by 0.8 will become 10. 10 with this 1000 multiplication become 10 to the power 4 and with 10 to the power minus 7 it become 10 to the power minus 3 and this 2 with 4 pi become 8 pi and our magnetic field flux density to middle position of this solenoid become 8 pi into 10 to the power minus 3 Tesla. A toroid has a known ferromagnetic core, so the permeability of this core medium is taken as permeability of air. Now the inner radius of solenoid core is 25 cm and outer radius is 26 cm, and around this solenoid core the total 3500 turns are wound, and if a current of 11 ampere passes through these turns, then we have to find out magnetic field flux density to inside space of this toroid, inside of the core of toroid, and to empty space outside this toroid surrounding toroid core. So at both inside the toroid and to outside surrounding space, the magnetic field flux density is 0, and this can be proved by Ampere circuital law at internal P position. When we take closed line integral of magnetic field flux density, then enclosed current becomes 0. So this line integral becomes 0 is possible only when magnetic field flux density in these internal empty space becomes 0. And for this outer empty surrounding space, once again when we take closed line integral of magnetic field flux density, it becomes mu0 times total enclosed current, and the algebraic summation of this dot and this cross current equal and opposite in direction becomes 0. So total enclosed current in this outer Amperean loop becomes 0, and this results in 0 value of magnetic field flux density to this outside surrounding positions. To find out magnetic field flux density inside the core of this toroid, we have to use this relation of magnetic field flux density mu0 small n I, where small n is number of turns per unit length of this toroid core, and it is given that total number of turns wound on toroid is 3500 and current in these turns is 11 ampere. We have also given that inner radius of toroid core is 25 cm and outer radius R2 is 26 cm. Now these two radius can be used to find out mean radius of this toroid core, and mean radius become 25.5 cm or 0.2555 meter. Now this mean radius is to find out mean length of toroid core over which these 3500 turns are wound, and turns divided by mean circular periphery of toroid core 2 pi r becomes number of turns per unit length small n, and our magnetic field flux density become mu0 times small n by I. Now the value of permeability of known ferromagnetic material is just like permeability of air, 4 pi into 10 per minus 7 Henry per meter. Number of turns are 3500 and the total length of toroid core is 2 pi small r and mean radius is 0.255 meter and the current is 11 ampere, and when we simplify this mathematical relation we get 3.02 into 10 per minus 2 Tesla value of uniform magnetic field inside the core of toroid. We hope this informative learning video has taught you each and every aspect of magnetic field produced by solenoid and toroid, and you can also handle the probable examination question too. Our other learning video of the same playlist are equally useful and you can use them in your study and share them with your friends. And if you need our support of online doubt clearing classes or dedicated exam centric notes, do join the membership of Sridevi Classes YouTube channel by clicking join button just beneath, and a small investment will enhance your scoring ability and success probability. Happy learning and have nice time. Thank you very much.